everyone, today we're going to be talking about nth roots and rational exponents. For this first video, we're going to be looking at real nth roots of a. So first, for just some background on nth roots, if b to the n is equal to a, then b is an nth root of a. So for example, 2 is a cube root of 8 because 2 cubed is equal to 8. So therefore, 2 is a cube root of 8. An nth root of a is written as nth root of a. So it looks really similar to square roots, which we've already worked with a lot. However, now there's this n here, where n is the index of the radical. So a note there, if I were to have a 2 here, this is the same thing as if nothing is there. So we always omit the 2 when we're taking the square root of a number. And something else that we see is that we can also write the nth root as a power of a. So for example, a to the 1/2 would be the same thing as the square root of a. And something we see with the power of a power property to rational exponents is that if I take a to the 1/2 and I square it, that is the same thing as multiplying 1/2 times 2 in the exponent, which is equal to 1, which is equal to a. And same thing with 1/3. If I take that to the third power, that's the same thing as a to the 1/3 times 3, which is equal to a to the first, which is equal to a. And so what this really means is that if I were to take the square root of a and I square it, that's just going to get me a. If I take the cubed root of a and I cube it, that's going to equal to a, and so on. And so in general, we see that the nth root of a is equal to a to the 1 over n power. And so we're going to be looking at real nth roots of a. And so let n be an integer where n is greater than 1, and let a be a real number. If n is an even integer, so if that root that we're taking is even, when a is less than 0, there are no real nth roots. So we talked about in the previous unit that if I take the square root of -9, that gets me 3i, that imaginary number. For this lesson, we're only looking at real roots. So the answer here would be no real roots. When a equals 0, there's one real nth root, and that's just going to be 0. And when a is greater than 0, there are 2 real nth roots. And that's going to be plus or minus the nth root of a, which is equal to plus or minus a square root of n. So from examples that we already seen, if I take the square root of 9, remember when there's no index here, there's really a 2. 2 is even, and so that means the answer here would be plus or minus 3, because 3 squared gets me 9, and -3 squared gets me 9. Now when n is an odd integer, when a is less than 0, there's one real nth root. That's just going to be whatever that nth root is. When a equals 0, there's one real nth root, which is just going to be 0. And when a is greater than 0, there is still just one real nth root. So let's look at some examples. I want to find the indicated real nth root of a. So for number 1, my n here is equal to 3. So n is equal to 3. A is equal to -216. And so I see my n here is odd. And I see that a here is less than 0. And so looking at my table, I see I am going to have one real nth root. And so I need to think, okay, what number cubed is going to get me -216? Well, since it's getting to a -216, I know it's going to be a negative number. And I see that -6 cubed gets me -216, because when I do -6 times -6 times -6, I get -216. So my answer here is -6. Okay, looking at this next one, I see my index here is 4, so n equals 4, which is even. And my a here is equal to 81, which is greater than 0. So looking at my table above, n is even, a is greater than 0. I know I'm going to have two real nth roots, so I need to put that plus or minus in the front. So here I need to think, what number to the 4th power gets me 81? Well, I see that 3 to the 4th gets me 81, and that's because 3 times 3 times 3 times 3 is equal to 81. And I also see that negative 3 to the 4th gets me 81, and that's because negative 3 times negative 3 times negative 3 times negative 3 is equal to 81. So my answer here is plus or minus 3. Okay, looking at this next one, I have the 5th root of 243. And so here, my n is 5, which is odd. And my a is 243, which is greater than 0. And so since it's odd, I know it's going to have one real nth root. So I'm looking to see, okay, what number, when I take it to the 5th power, is equal to 243. So what number, if I multiply by itself 5 times, gets me 243? Well, that's going to be 3. So the answer here is 3. Looking at this last one, my n here is 4, which is even. And my a is equal to 16, which is greater than 0. So I know I'm going to have two solutions here. I'm going to have the positive and the negative. So looking to see what number raised to the 4th power is equal to 16, I see that's going to be 2. So my answer here is positive and negative.